Welcome to the AI for Career Success podcast by Curt Robbins. We're experts at AI coaching and helping professionals like you and your employees upskill in AI. I am Fred Jones, and this is episode 211. Joining me today is my co-host, Daphne Blake. Daphne, we think of AI as this, kind of digital magic, pure code floating seamlessly in the cloud. But right now, the entire AI revolution is actually stuck waiting for concrete to dry and copper wires to be laid.
Yeah, it's a massive blind spot for a lot of people in tech, Fred. To really unpack why this is happening, we're going to look at a highly revealing article published on LinkedIn. It's by Emma W. Thorne, and it's titled, Big Tech's Great AI Build-Out is Hitting Some Hurdles.
And what makes Thorne's piece so crucial isn't just her reporting, right?
Exactly. It's the tidal wave of commentary it sparked on the platform. You have contractors, engineers, and supply chain managers chiming in, the people who are literally in the trenches of this infrastructure crisis.
There is this incredible irony at the heart of all this. We are talking about the most advanced digital technology in human history, backed by just an unfathomable amount of capital. I mean, Alphabet, Amazon, Meta, and Microsoft.
The big four?
Right.
Yeah.
They are collectively expected to spend over $650 billion by 2026 just to expand their AI capacity. That's like having an unlimited budget to build a fleet of spaceships, but you can't get your hands on a single titanium screw to actually put them together.
It's actually worse than just missing screws. According to the research from JP Morgan that Thorne cites in her article, more than 60% of the data center capacity plan for 2027 isn't even under construction yet.
Wait, 60% hasn't even broken ground?
Yeah.
With $650 billion on the table.
Zero ground broken. Not a single shovel in the dirt. The industry is currently tracking about 140 active projects meant to deliver 16 gigawatts of capacity before the end of the year. And just to put that number into perspective, 1 gigawatt can power roughly 750,000 homes.
Oh, wow. So 16 gigawatts is enough power for like 12 million homes. That's a massive undertaking.
Huge. But out of those 16 gigawatts, only about 5 are actually being built right now.
Okay, so if capital clearly isn't the bottleneck here, what exactly is causing this massive delay?
Yeah.
Because you can't just throw $1 billion at a concrete foundation and make it cure faster.
Right. The bottleneck is the sheer physical limits of the global supply chain. Christian Young, one of the industry experts who weighed in on Thorne's LinkedIn article, pointed out that the construction industry is being asked to move at a pace it was never designed to sustain. We aren't just talking about building standard warehouses here.
We're talking about facilities that need incredibly specialized components, right? With severe lead times.
Precisely. You can't just plug 50,000 AI servers into a standard wall outlet. You need massive, highly specialized industrial switchgear.
Think of them as giant, incredibly complex circuit breakers.
Yeah, exactly, to handle that electrical load without catching fire. Those components currently have a 2-year backorder. And that doesn't even touch on the delays for industrial-scale transformers.
And a delay in building these transformers doesn't just pause the construction of one data center in one city. It creates this crazy global bidding war for materials. You see the ripple effect everywhere.
Oh, absolutely.
Like another commenter on Thorne's article, Paul Dixon, noted that memory chips alone are up 600% year over year. The AI build-out has strained resources across so many different heavy industries that you simply can't isolate the problem.
That interconnectedness is the real danger. A shortage of high-grade copper in one hemisphere means an AI deployment delay in the other.
So if you are a manager or an executive listening to this, and you're planning your company's AI integration over the next 3 years, this is why you need to care. This bottleneck is going to directly impact your software costs, your processing availability, and your implementation timelines.
The cloud is going to get very expensive very fast.
Exactly, because the physical hardware running it is log-jammed.
That is a really vital takeaway, Fred. Jeffrey Dorff, another professional who commented on the thread, synthesized this perfectly. He called this an infrastructure execution cycle. Having all the funding in the world and employing the most brilliant software developers means absolutely nothing without relentless supply chain discipline.
It requires a level of operational execution that goes way beyond traditional software development. It's not just about writing the code, it's about whether you have the municipal permits and the industrial electrical components to power the server that runs the code.
Which is a whole different ballgame.
It really is. Well, before we explore how some companies are actively trying to solve this massive operational puzzle, let's take a brief break for a special message from our producer, Curt Robbins.
Hi, this is Curt Robbins. First, thanks for listening. I truly appreciate your support. I want to let you know that I'm currently accepting new clients. My rates are affordable, and I have more than 25 years of experience working for enterprise companies like Microsoft, Northrop Grumman, Oracle, PNC Bank, FedEx, USAA, and Wells Fargo, among many others. If you want to improve your IT documentation and communications, hire me. I deliver fast, know how to use AI to improve efficiency and accuracy, and love going the extra mile to satisfy my clients. Thank you for subscribing and listening. Back to you, Daphne and Fred.
Welcome back to the AI for Career Success podcast, where we help you get smarter than your competition by coaching you in AI.
All right, Daphne, so I have to challenge the premise a little bit here. We are talking about trillion-dollar tech companies. They employ the smartest logisticians and strategists on the planet. I mean, Emma W. Thorne's article mentions Google stepping up to solve this, specifically by acquiring renewable energy developers and building in-house energy expertise.
They are.
But aren't they just trading one bottleneck for another one? Now, instead of waiting in line for a traditional utility transformer, they're waiting for solar panels, wind turbines, and battery storage. How does that actually speed anything up?
It's a fair challenge, Fred, but it really comes down to bypassing what the industry calls interconnection queues.
What does that mean, practically?
Usually when you build a massive data center, you have to apply to the local utility grid for permission to connect and draw power. Because the grid is so outdated, those approval queues can take years. By acquiring renewable energy developers and building their own microgrids, Google is fundamentally bypassing that waitlist.
Ah, I see.
Yeah, they aren't waiting for the local city to upgrade a substation. They are generating the power themselves right at the source.
Okay, that makes sense. They are taking control of the variable they can actually influence.
And it goes even deeper than that. Commenter Christian Grandy highlighted Google's use of demand response programs. They aren't just generating their own power, they are actively controlling exactly when their data centers consume energy.
How does that work in practice?
Well, AI training models are incredibly power hungry, but they don't necessarily have to run at 2:00 p.m. on a Tuesday when the rest of the city is blasting their air conditioning.
Right.
Through demand response, Google can throttle down non-essential compute tasks during peak grid hours and then ramp up heavy AI training at night when grid demand and energy cost is practically zero.
No.
They've vertically integrated the actual behavior of the power grid into their AI strategy.
That is brilliant. They aren't just asking for more electricity. They're changing the shape of how they consume it. This completely changes the dynamic of the AI race for our listeners to consider. The winners in this build-out aren't necessarily going to be the ones with the biggest wallets.
Right, because Microsoft, Meta, and Amazon all have essentially infinite capital.
Exactly. The winners are going to be the contractors, the engineers, and the tech firms who can solve this physical operational puzzle. It's the teams who plan early, secure raw materials, and manage risk with extreme discipline.
Yeah, as Justin and Malia pointed out in the discussion, even with strong supply chain relationships, these projects are incredibly challenging to land on time.
It shifts the entire focus of the AI revolution from software engineering to heavy industrial execution. You need executives who understand the dirt and steel reality of construction just as intimately as they understand neural networks and machine learning.
It really pulls back the curtain on how fragile our technological leaps can be when they collide with physical reality.
It does. And that is a fascinating perspective to leave you with today. We naturally think of AI as this, ethereal thing living up in the cloud. But the truth is, the cloud is incredibly heavy. It is made of concrete, steel, copper, and massive amounts of electricity. The ultimate ceiling on how smart or how pervasive AI can become in your daily workflow might not be decided by software engineers in Silicon Valley at all. It might actually be decided by city planners, local electricians, and the physical limitations of the power grid down the street.
Thank you for listening to the AI for Career Success podcast from Curt Robbins, where we help you get smarter than your competition. Please buy us a coffee and remember that we're experts at coaching you and your employees about AI.